let's solve for double integrals, but this time your bounds will be functions. What do I mean by that? Well, previously you had some very nice bounds like 0 and 1 for x and 0 and 2 for y. They're no longer going to be constants. They're going to look something like maybe this, or your functions will be bounded like, I don't know, this, x squared. So for our first problem, we're going to be integrating upon x and 2 and 0 and 2 with our function e to the power of y squared dy dx. Now take a look at this. Try to solve this like you normally do already, or from what you learned up now. You can't solve this. Well, maybe you can, but it'd be very a lot harder than just switching your order of integration. So try to solve for e to the power of y to the power of 2 with respect to y. You just can't do it. So first thing we're going to do is let's draw out our graph. Always helps to draw out the graph. And let's draw out our bounds first. So our first bound is the y bounds, and the y is bounded by 2 and x. So our y is bounded by 2. So this is y equals 2 and x, which is just y equals to x. So this function is y equal to x. And our x is bounded from 0 to 2. Now, we have two triangles. Which one do we shade in so we know which one we're integrating upon? Well, you can actually tell based off the order in which this integral is placed. So when you're integrating with respect to dy, the top integral is the top bound, and the bottom, well, the top value is the top bound, and the bottom value is the bottom bound. So if y equals 2 is our top bound here, and y equals x is our bottom bound, so between y equals 2 and y equals x is simply this shaded region. And let's just write down x equals 0 and x equals 2 for this. Now that we have that out the way, we can switch our orders of integration. How can we do that? Well, you want some values of your double integral, some region. Let's leave r. And we want to switch it so we integrate with respect to x first. How do you do that? Well, if you want to integrate with respect to x, when you integrate with respect to x, the top bound, so bound b, is the right value, is the rightmost value, and the bottom bound is the left value. What I mean by this, or the left bound? Well, our right bound with respect to x, right? So along the x-axis, what's to the right of this triangle? To the right of this triangle is our function, y equals x. But how do you isolate x in this case? Well, all you have to do is just switch the order here. But x is already isolated, so our function stays the same. What is our left bound here? So our a value that we're going to get. Where a value is just x equals 0. So our first bounds are 0 at the bottom, because the bottom, remember, the a value is the left bound here. And our top value up here in the integral is the rightmost bound. And our right bound along the x-axis, so from left to right, is this function here. Y is equal to x. But since we're integrating with respect to x, plug in for y. Now how about our y bounds? Well, our y bounds are already written down here. Y goes as low as 0. This point is 0, 0, the origin. So y goes as low as 0. And how high does y go up to? Y just goes up to y equals 2. So now that we switched our order of integration, what can we do? Well, let's try this out now. Let's see if this is possible. So 0 and y, e to the power of 2, dx, dy. write down an arrow. dx dy. And let's integrate this with respect to x. So with respect to x, e to the power of y squared is just multiplied by x, because this is treated as a constant when you're integrating with respect to x along the bounds of 0 and y. Set this equal to x to know that we're integrating with respect to x right now. And we can just plug in our values for y into x. So e to the power of y, we can actually just plug in this value for y up here, or down there technically, and then we get y times e to the power of y squared. And we just plug in 0, just get 0. So this is our answer for this integral here. Now that we've actually, sorry, I wrote dy here as well. Not supposed to be there. So now we have this integral solved for with respect to x first. Now we just solve with respect to y, and we just plug in for our y bounds that we got, 0 and 2, and our function e to the power of y squared with respect to y. And if you find the integral of this, you use some u sub, right? You get, actually, I'll write down the u sub for you guys. So I'll set u equal to y squared because that's at the top. That's what we're chaining. And du is equal to 2y dy. Therefore, du over 2y is equal to dx. Now if we write down y times e to the power of u, because y squared is equal to u, and dy is equal to, it's not dx, sorry, or dx down here for some reason. dy is equal to du over 2y. And these y's cancel out, matter of fact. So you get left off with 1/2 e to the u. Integral of 0 to 2, 1/2 eu du. If you integrate e to the power of u, it just stays the same. So you get 1/2 e to the power of u as your integral. But we can just turn the u back to y squared because u is equal to y squared, and then we write our bounds of 2 and 0. Now if you solve for this integral, you'll get e 1/2 e to the power of 4 minus 1/2 e to the power of 0, which is just 1/2. So this right here, let's use blue. This right here is our integral using function bounds and switching the order of integration of this guy up here. So for problem 2, our integral this time will be upon the integral of 1 y over 2 upon the bounds, not upon the integral of. And our function will be cosine of x squared dx dy. So first, let's draw our graph. So our x-axis, this is our y-axis. And our x bounds are bounded by the function x equals 1. So maybe this is hidden or not. Maybe you don't know this, but this is our function here. And it's bounded by the function x equals 1, which is this. Let's remove some of those dots. And y over 2, or x equals y over 2, which is something like this. And our y bounds are from 0 to 2. So right now we have our, what is this? This is y over 2 function is equal to x, and x is equal to 1 here. And this is our y function. Y is equal to 2, and y, not that, y is equal to 0. So, how do we switch the order of integration? Well, first let's set it up. So, write an arrow. We have two integrals with our function cosine x squared dy dx. Now we are looking at our y and x bounds. And technically this is the region here. It's the only region bounded by all of these restraints. It's not this one, because if it was this one, there is no left side bound. So it's not this side of the triangle, since there's no left side of the bound. This is the only one bounded by all the restraints. So now that we have that, let's go evaluate our y boundaries. Well, our first y boundary, so remember the top of the integral is our top bound. And the bottom of our integral is just the bottom bound. So some function, some constant, something that represents the boundary. So our top bound will be y over 2. But we have to, I don't know if you guys heard that Discord ping, bro. But, okay, let's keep going on with the video. So our top bound is x equal to y over 2. But we need to isolate, we need to isolate our, oh my god, I wrote this wrong. This is, dx is, wait, no I didn't. Hold up, let me think. X is equal to y over 2. Yo, I'm stupid, bro. Okay, oh. No, I just had a brain fart. No. We need to isolate. We just need to isolate y in order to get our function for y. So this is our top bound. This is what bounds the triangle on the y-axis. So this function right here, y over 2 equals x, bounds our region at the top. So in order to do that, we just need to isolate y, and these two functions just equal each other. 2x is equal to y. So now our top bound is 2x, sorry. And our bottom bound is just 0 for this triangle in the y-axis. How about our x bounds? Well, our x bounds are just from 0, which is the origin here. It's the leftmost this triangle can get. And the rightmost this triangle can get is x equals 1. So our right bound, which is at the top of the integral when we're integrating with respect to x, is 1 here. Now all you have to do is just solve for this. So let's go ahead and solve for the first integral. The first integral is with respect to y, dy. And all you get is cosine x squared from 0 to 2x equal to y. I need to mute that server. Now that we found this integral, all we do is just plug in the value for 2x into y. And plug in the value for 0 as well, but 0 just turns everything to 0, so we don't need to plug 0 in. So we plug in 2x, you get 2x cosine of x squared. Now, all we have to do is integrate with respect to x now. So now this integral is possible. At first, you cannot integrate this with respect to x. It would be very, very annoying and difficult if you were to try to. But if you switch the order of integration, now we have something that's easily use-subbable. So our x bounds are from 0 to 1. We have 2x cosine x squared with respect to x. So we integrate with respect to x. All we get is sine of x squared from 0 to 1. And then if you plug in all your values, you get sine of 1 minus sine of 0. And this is just equivalent to sine of 1, because sine of 0 is just 0. That's your answer. This is your area in, I think it's probably radians. I don't know, 1 radian. for the area of this triangle. Now, for the last problem, I'm just going to switch the bounds. I'm not going to do anything else because solving for this is a little crazy. DeepSeek gave me kind of a crazy problem for this. It's not that crazy, it's just tedious and I don't want to do it. So it doesn't matter what our function is, I'm just going to leave it like this. So our function, this is supposedly, the actual function that DeepSeek gave me was like y, sine of y. So if you want to solve this, then go ahead and try it, but I'm just going to show you how to switch the order of integration. So in order to switch the order of integration, let's draw the graph first. So our graph, x, y. So our y-axis is bounded by, or our y values are bounded by x squared and 4. Let's go ahead and draw that. This is y equals to 4. And x squared looks something like this. And this is y is equal to x squared. Our x bounds are bounded by 0 and 2. So this right here is just x equals, this is x equals 2, this is x equals 0. So how do you switch the order of integration? Well, let's set up the integral first. So if we set up this, we have our function f of x, y. And we want to change it so that you integrate with respect to x first. That's why I switched it from dy dx to dx dy. How do you do that? Well, remember in our, and actually let's shade out the region first. Sorry. So in order to determine which region we're shading out, maybe this one or this one. How can you tell? Well, you can tell based off of our y bounds here. Our y bounds have 4 at the top, therefore 4 is our top bound for y. And x squared is the bottom bound for the region. So 4 is the top bound, x squared is the bottom bound. And what's below 4 equals y, and what's above x squared is this region here. Now that we have that region, all we have to do is find our x bounds now if you want to switch it. So we need to find the bounds for the x axis. So how do you do that? Well, remember for integral, if you have some function and you're trying to integrate with respect to x, the top is the right bound and the bottom is the left bound. Sorry for the bad handwriting. I'm just writing fast. So how do you solve for that? Well, the right bound is defined by x squared, but you can't plug in x squared into x, right? So you need to isolate x. And how do you do that? Well, if you just isolate x, square root both sides, you get square root of y divided is equal to x. And the reason why it's not plus or minus is because we don't have a square root function down here as well. So this is just the positive version of this. So it's the plus and the plus or minus. If you add a plus or minus, your function would look like this. And that wouldn't make sense in the context of our integration. Now that we have square root of y as the rightmost boundary, the rightmost boundary goes at the top of the integral. So when we're integrating with respect to x, the right boundary goes at the top. So square root of y goes up here. And the leftmost boundary is x equals 0, which is just 0. How about our y boundaries? Well, this region right here only goes up to 4 and only goes down to 0. So our y bounds are just 0 and 4. So if you have any questions, put it down in the comment section.